Hello everyone. So now we're going to do 6.1b. So hopefully you already have it printed out. If not, you know the drill, you need to print it out. So I will start by putting it up so you can see it. So not just me seeing what I'm doing. All right. So this section is of irrational inequalities. So if you remember in 5.1, we did the polynomial inequalities, and then in the last lesson, 6.1a, we did rational functions and their vertical and horizontal asymptotes. So this is going to be dealing with rational inequalities, so it's going to be fractions, but the process is going to be pretty similar to 5.1, where we're using the sign test method. So this should feel familiar if you've watched 5.1. If you haven't watched 5.1, you should probably do that before watching this video. So like I just said, the rational inequalities are solved the same way as the polynomial inequalities, or at least in a very similar way. So we are using the sign test method, just like we did in 5.1. So, and we're also going to be writing our answers as intervals, just like in 5.1 as well. Okay. So the 4 steps to this sign test method are pretty much the same. The difference is in step 1, we're going to find those zeros at the top of the fraction and the bottom of the fraction, instead of just having a polynomial, since we have a rational inequality there. So find the zeros at the top, p of x, and the bottom, q of x. So really, before we can get into those 4 steps, we need to have it into this form where it's p of x over q of x is greater than 0, or p of x over q of x is less than 0. So there are going to be a couple of examples where we start out and it's not in that form, so we're going to switch it to be in that form before we start with the 4 steps. And you'll see what I mean when we get to them. So once we find those zeros, those are going to be the test points, like they were in the previous lesson in 5.1, which means they're not your answers, but you're going to use them to find your answers. So once we find the test points, we're going to plot the zeros on a number line, just like we did before. Plot them in the correct order, you know, smallest numbers first, biggest numbers next. And then we test the points to see if the inequality is true or false. So keep the true intervals, throw out the false intervals like it was in 5.1, and then write the solution in interval notation. Okay. So the last part of this is we think about what the bottom is going to do to our endpoints, like brackets or parentheses. So if we are finding zeros from the bottom of the fraction, so q of x, in the first step, we're going to set that equal to 0. And if that's equal to 0, that means the bottom of our fraction is equal to 0, which means we're dividing by 0. So if those numbers make us divide by 0, we think about, is that going to be a bracket or a parentheses? We can't include it because it's dividing by 0, so we should use parentheses for those. But the numbers that come from the top of the fraction, you have to look at the sign. So I'm going to say numbers that come from the bottom of the fraction, or numbers that make bottom 0, always get parentheses. The numbers that make the top of the fraction 0, you have to look at the inequality sign. Hold on, to write that below. And so what that means is strict inequalities are going to get parentheses, and the inclusive inequalities are going to get brackets. Okay. So with each one of those, you'll have to say, okay, is this a point that makes the bottom equal to 0? If so, we automatically get parentheses. If it is something that comes from the top equaling 0, well, we'll have to figure out that from these signs here. Okay, so let's jump into some examples. Okay, so step 1 says we set the top equal to 0, set the bottom equal to 0. So 4x equals 0. We solve for that by dividing by 4. We get x equals 0 from the top. So now we set the bottom equal to 0. Subtract 6, and we get x equals -6 from the bottom. So in that case, we are getting 2 test points. And so we'll have -6 first and 0 second, because -6 is less than 0. So you can see we have sort of 3 intervals to work with. We've split up our number line into 3 different parts. And so we will pick a number from each part and do the sign test. So that is step 3, is the sign test. So we start by picking a number from the first interval, so something less than 6. And we can pick, less than -6. So we can pick -7 and plug that in. Or your favorite number less than -6. If you want to pick something else, go for it. So if we plug in -7, the top is 4 times -7, and the bottom is -7 plus 6. And so we want to see if that is less than or equal to 0. So 4 times -7 is negative, so we've got a negative on top. And then -7 plus 6 is negative, so we have a negative on the bottom. And we think, is that less than or equal to 0? Well, a negative divided by a negative, like a negative times a negative, is a positive. So we have positive less than or equal to 0. That's not true. And so this interval is not true, and we don't include it, so we're not going to shade that interval. And so we will test the next one. We'll pick a number between -6 and 0. And we don't want to pick -6 or 0 themselves. We want to pick a number in between, because if we pick -6 or 0, it's just going to either give us 0 at the top, or we're going to divide by 0, and we don't want either one of those things to happen. So if we pick a number in there, I'm going to pick -1 and plug that in. We have 4 times -1 on top, and then -1 plus 6 on bottom. And so on top, or we want to see if that's less than or equal to 0. On top, that is a negative, and on bottom, that is a positive. So negative divided by positive is a negative, and negative numbers are less than or equal to 0. So this inequality is true. So that one is yes. And that means we will shade this interval. So the last interval, we'll pick a number greater than 0. So I'll just pick 1, plug it into the top, so 4 times 1, plug it into the bottom, we get 1 plus 6. We'll have to see if that's less than or equal to 0. It's a positive number on top, and it's a positive number on the bottom. Positive divided by positive is positive. And so we ask, is positive less than or equal to 0? The answer to that is no. So since that is a no, that means that this inequality that we started with is false. And so we don't include that interval. Okay? So let's give ourselves a little bit more room for part 4. So now part 4, we want to take the intervals we shaded here and write them in interval notation. But first we need to figure out, are we using brackets or parentheses around it? So first we'll think about -6. -6 came from when we set x plus 6 equal to 0. And x plus 6 is the bottom of the fraction. So what we got there is that when we plug in -6, the bottom of the fraction is becoming 0. And we can't divide by 0, so that means that -6 cannot be included since it came from the bottom of the fraction. So that one's going to get a parentheses. So just like I said at the bottom of this page, the numbers that make the bottom equal to 0 always get parentheses. So now we think about 0. That x equals 0, the way we got it is by setting 4x equal to 0. And 4x is on the top. So that means that the way we figure out what endpoint to use, we have to look at this inequality. So since that is an inclusive inequality, we want to make sure that we include our point 0, and so that gets a bracket. So now we have determined that -6 gets a parentheses, 0 gets a bracket, and so for step 4, we'll write this interval in interval notation. So it starts at -6, ends at 0. -6 gets a parentheses, 0 gets a bracket, and that is our final answer. Okay. So that is the answer for step 1, is -6 to 0. So for question 1. Okay. So we'll go through the same 4 steps with question 2. But question 2 is in a little bit different form. So if we go back up, we want it to be in this form like we see it here, where it's the fraction on one side, 0 on the other, and then the inequality sign in between. So we really want to get everything to one side and just 0 on the other side. So let's move this over. So we've got -3 over x minus 2. So what we can do is we can add 3 over x minus 2 to both sides. And so we're getting -3 over x plus 5 plus 3 over x minus 2 is less than or equal to 0, because what we were doing is we were canceling that. So now we have 2 fractions being added together. We want it to be one fraction. So to add fractions together, we have to have a common denominator. So what I will do is I will multiply this first fraction on top and bottom by x minus 2. And the second fraction, I will multiply it on top and bottom by x plus 5. And so we end up with -3 times x minus 2 over x minus 2 times x plus 5. And then plus 3 times x plus 5 over x minus 2 times x plus 5. And then that's all less than or equal to 0. Okay. So now we can combine the fractions together. So -3 times x minus 2 plus 3 times x plus 5 all over x minus 2 times x plus 5 is less than or equal to 0. And then I'm going to actually move up over here. And we're going to get -3x, or we're going to distribute this right here, -3x plus 6, and then we'll distribute this 3. So plus 3x plus 15 over x minus 2, x plus 5, and that's all less than or equal to 0. Sorry if you couldn't quite see that. So we'll simplify that top part. Negative 3x and 3x cancel each other out. And then we have 21 on top. And then, hold on. Sorry, 21 on top, and then x minus 2 and x plus 5 on bottom. All right. So once we get that, we have it in the form where it's a fraction on one side and 0 on the other. So now I'm going to make this all a lot smaller and give myself a lot more room, because we have to do the actual 4 steps of the problem. All right. So step 1, we'll set the bottom and the top equal to 0. So if we set the top equal to 0, we just get 21 equals 0, and that doesn't make any sense. So saying the top equal to 0 is not going to give us any points. So we're just going to set the bottom equal to 0 in this one. So x minus 2 equals 0, and then x plus 5 equals 0. So add 2 to both sides. We get x equals 2, and here we'll subtract 5 from both sides, and we get x equals negative 5. Okay, so those are our test points. So now step 2 is the number line. So negative 5 comes first because it is a smaller number, and then 2 comes next. Then we will use the sign test in step 3 on each of the 3 intervals, 1, 2, 3, that were created by plugging in our test points onto the number line. So let's first test the interval that's less than negative 5. So I'm going to plug in negative 6, and I'm going to plug it into this version, the version that is in the form that we want. So if I plug in negative 6, then I'm getting 21 on top, which is a positive number. Then on the bottom, I'm getting negative 6 minus 2, which is negative. And then negative 6 plus 5, which is also a negative. And then we want to see, is that less than or equal to 0? So a positive over a negative times a negative is you're gonna think the bottom is like negative times negative, which is positive. So this is essentially a positive over a positive, which is a positive number. Okay. So if you want, I can write out the steps. So it's positive on top, and then negative times negative is positive, and positive divided by positive is positive. So we got positive less than or equal to 0. That is not true. So since it is not true, this interval, we'll write no, and we will not include it and not shade that. So now we'll test something from the next interval, something in between negative 5 and 2. So I'm going to pick 0 because it's an easy number to plug in. So the top is 21, which is a positive number. The bottom, when we plug in 0, we get 0 minus 2, which is negative. And then 0 plus 5, which is positive. And we'll test if it is less than or equal to 0. So it's positive on top. On bottom, negative times positive is a negative. And positive divided by negative is negative. So we're asking, is a negative number less than or equal to 0? And that's true. So this interval, we will write yes, and we will include that interval there. Okay? So we will plug in a number from our last interval, which is something greater than 2. So if we pick a number greater than 2, I'm going to pick 3 and plug that in. So the top is 21, which is positive. The bottom is 3 minus 2, which is positive. And then 3 plus 5, which is positive. And we ask, is it less than or equal to 0? So positive divided by 2 positives is positive. And positive numbers are not less than or equal to 0, so that one's a no. And so this interval gets no as its answer. All right, so now we've got those, and I'm going to make step 3 a little smaller and give some room for step 4. And I'm going to have to do step 4 off to the side over here. Okay. So in step 4, we need to figure out whether we're using brackets or parentheses. So if we think about -5, -5 came from the bottom of the fraction when we plugged this x plus 5 and said equal to 0. And so if we plug in -5, we're dividing by 0, so we can't do that. So we can't include -5, so it gets a parentheses. The same thing with -2, or positive 2. Positive 2 came from when we plugged in, when we set x minus 2 equal to 0, and x minus 2 comes from the bottom. So that 2 comes from the bottom. We can't have the bottom equal to 0, so we're getting a parentheses there as well. So in the end, we will have our interval here. The shaded part goes from 5 to 2, and they both get parentheses because they're both numbers that came from when we plugged the bottom of the fraction equal to 0. And so that is the final answer for number 2. Okay. So now we will go on to number 3. I'm going to make that a little smaller just so we can have number 3 all together. Okay. So number 3, we need it to be in a form where it's one fraction on one side of the inequality and 0 on the other. So let's move this fraction over to the other side. So I'm going to subtract x over x plus 4. And we'll get 3 over x plus 4 minus x over x plus 4. It's greater than or equal to 0. We want it to be in one fraction. And adding and subtracting fractions means we need a common denominator, but this one we got lucky. They actually happen to be the same denominator, so we don't have to make a common denominator. We already have one. So we'll end up with 3 minus x over x plus 4 is greater than or equal to 0. Okay. And so then we can go on to the 4 steps of the sign test method. So step 1, we're going to set the top equal to 0 and then set the bottom equal to 0. So 3 minus x equals 0. We add x on both sides. We'll get 3 equals x, or x equals 3. And then the bottom, x plus 4 equals 0. We'll subtract 4, and we'll get x equals -4. And so for step 2, those two go on a number line. -4 comes first, and 3 comes second. So then we'll go on to step 3, which is the sign test. Okay. So for step 3, we will plug in numbers from each of the 3 intervals that we just created. So let's start with a number that is in that first interval, something less than -4. So we'll try -5. And I'm going to plug it into this version. So you can plug it into the original, but that would be a lot more complicated. So let's do this one here. So we plug in -5, we're getting, on the top, we're getting 3 minus a -5. That's 3 plus 5, which is a positive number. On the bottom, we're getting -5 plus 4, which is a negative number. And we want to see, is that greater than or equal to 0? So positive divided by negative is positive. Sorry, no, it's negative. And so we ask, our negative number is greater than or equal to 0. And so that is not true. And so this interval is no. So then we will test the next one. So a number between -4 and 3, 0 is good to plug in. So we're going to plug in 0. On top, we get 3 minus x is 3 minus 0, which is positive. On bottom, it's 0 plus 4, which is positive. We ask, is that greater than or equal to 0? So positive over positive is positive, and that is greater than or equal to 0. That is true. So this one is yes. So since it's yes, we will shade that interval. And then next we will test the last interval, numbers greater than 3. So I'm going to pick 4. When I plug 4 in, I get on top, I get 3 minus x, which is 3 minus 4, which is negative. On bottom, I get 4 plus 4, which is positive. And we ask, is that greater than or equal to 0? So negative over positive is a negative. And we say, are negative numbers greater than or equal to 0? That is not true. So that one is no. Okay. So at the end, we just have that one interval that is included. And for the fourth step, we just need to figure out brackets or parentheses and then write an interval notation. So -4, that came from when we plugged in, when we set x plus 4 equal to 0. And x plus 4 came from the bottom of this fraction here. So since it came from the bottom, it's making the bottom equal to 0. So that one is not going to be included. And so we're going to get a parentheses there. 3 came from when we set 3 minus x equal to 0, which came from the top. So since it came from the top, the way that we figure out whether to use a bracket or parentheses is we have to look at this sign. It's also the sign of the original equation. So that is inclusive. So it gets a bracket. If it was a strict inequality like this and it didn't have that little part down there, then you would use a parentheses there. So now we write this interval as -4 to 3, where -4 gets a parentheses and 3 gets a bracket. And that is our final answer. All right. And now I think this next one is the last example on this section. Yes, it is. So example 4 is the last one. Okay. So we want it all on one side, 0 on the other. So let's move this over. So we're going to subtract x over x squared minus minus 12 on both sides. These fractions will cancel. And on the left side, we have -1 over x squared minus x minus 12, and then minus x over x squared minus x minus 12 greater than or equal to 0. So now we need to add and subtract them, put them all as one fraction, and we're lucky again, we have a common denominator already, so we don't have to make one. So we'll do -1 minus x, and then on the bottom, x squared minus x minus 12 is greater than or equal to 0. And I'm going to go ahead and I'm going to factor the bottom of that because that's going to make our calculations in the next few steps, it's going to be necessary for it. So we're just going to go ahead and do that. So -1 minus x, we factor the bottom. We'll have x and x. Our factors of 12 are 3 and 4. And then to make this negative x on the inside, we're going to need a -4 and a positive 3. And then the greater than or equal to 0 stays. And so let's make that a little smaller. And so now we should be able to do the 4 steps of the sign test method. So step 1, set the top equal to 0, set the bottom equal to 0. So we'll have -1 minus x equals 0 on the top. So add x to both sides and get -1 equals x, or x equals -1 if you'd rather write it that way. And then the bottom, we get x plus 3 equals 0. Subtract 3 and we get x equals -3. And then x minus 4 equals 0, add 4. And we get x equals 4. So now we go on to step 2. And we put those numbers on the number line in the correct order. So we'll do -3, -1, and 4. So step 3 is the sign test. So we will start with the first interval. We'll plug in a number that is less than -3. And I think I actually want to do this up on the other side of this. I don't want to do it down because I want to be able to see the entire problem at once. So I'm going to do step 3 over here. Okay. So we're going to plug in a number from the first interval, something less than -3. So I'll choose -4, and we want to plug it into this form that we got it in, the form that we need. So when we plug in -4 on the top, we get 1 minus a -4. So that becomes 1 plus 4, which is a positive number on the top. Then on the bottom, we have -4 plus 3, which is negative. And then -4 minus 4, which is another negative. And we want to see, is that greater than or equal to 0? So the top is positive. The bottom is a negative times a negative, which is a positive. And we say, is that greater than or equal to 0? Positive over positive is positive, so that is greater than or equal to 0, yes. And so, yes for this one, and that means we shade this portion of the number line. So next, we'll plug in a number between -3 and -1, so -2. On the top, we will have, on the top, we have -1 minus a -2, so that's -1 plus 2, which is positive. On the bottom, we have -2 plus 3, which is positive. And then -2 minus 4, which is negative. And ask, is it greater than or equal to 0? So we have positive on top, negative on bottom. Positive over negative is a negative. And we say, is that greater than or equal to 0? And it's not. So no for this one. Okay. The next interval, something between -1 and 4, I'm going to choose 0. And so on the top, we have -1 minus 0, which is negative. The bottom, we have 0 plus 3, which is positive, and 0 minus 4, which is negative. And we ask, is it greater than or equal to 0? So negative on top, negative on bottom. Negative divided by negative is a positive, which is greater than or equal to 0. Yes. So yes for this interval. We will shade it and then go on to test the next one. Okay, so we'll pick a number that's greater than 4. So I'm going to pick 5. And then we're going to plug it into this form that we put it in, fraction on one side, 0 on the other. So the top, -1 minus 5 is negative. We have 5 plus 3 is positive. Hold on. There we go. So 5 plus 3 is positive. And then we plug it into the next one, 5 minus 4, which is positive. We ask, is it greater than or equal to 0? So negative on top, positive on bottom. And that is a negative. And is negative divided by positive is negative. And it's not greater than or equal to 0. No, not true. And so in the end, we just have those two intervals being correct. So now let's check whether we get brackets or parentheses on each one. So the numbers we got from the bottom of this fraction, the x plus 3 and x minus 4, those numbers are that -3 and that 4. So since the -3 and 4 came from the bottom of the fraction, we automatically know that those are going to get parentheses because we can't divide by 0. So -3 gets a parentheses and 4 gets a parentheses. The 1 here came from the top of the fraction. So that the way that we determine what sign that 1 gets, or what end mark, is going to be from the inequality sign. So that is an inclusive inequality, and so that means we use a bracket. So now we can do step 4. This first interval goes from -infinity to -3. Negative infinity always gets a parentheses because it's not a real number, and 3 gets a parentheses because it has a parentheses in this number line. Then the second interval, -1 to 4. 1 gets a bracket and 4 gets a parentheses. And then since we have two intervals put together, we have to put the union sign in between them. And that is the final answer for number 4. So that is all the questions that we have for this section. And that should finish up all of the lessons that will be on test 3. So for test 3, remember one section, it was 4.2, I believe. Let me check. It was 4.2a. 4.2a we covered in class the week before spring break. And then the other lessons that will be on test 3 will be 5.1, 5.2, 6.1a, and 6.1b. So if there are any questions about those, let me know. You can email me or come to the virtual office hours on Zoom. So hopefully things will go well, and feel free to ask me any questions that you want. All right, so I will see you when we start videos for test 4 cycle. All right, have a good day.